Design of moment resisting base plates, in which the third case is when eccentricity is greater than L by 3. If we divide this is L by 2 and this each part will be L by 6, and up to here it will be L by 3. So eccentricity E is greater than L by 3. So our load P is acting here. This creates large amount of tensile forces which causes the slab to lift up. To avoid that, anchor bolts are provided at a distance of say A from the center, and let us say this width is B and length is L. Then let us say X is the distance up to which the compression force exists. So this is X and this is B. So our effective area is now B into X. So this is the contact area, and approximating the distribution to be a rectangular one, and this ordinate as 0.45 FCK, then this distance will be X. So the compression force will be equal to 0.45 FCK into X, area of the pressure distribution. From top, the P load is acting at an eccentricity of E, and the force in the bolt, let us say it is FB, which acts at a distance of A from the center. So our compression force is 0.45 FCK into X into B is the width of the beam, so the width of the slab, into B. Separately taking the approximate distribution, this is the load P, this is force in the bolt acting at a distance of A, P is acting at an eccentricity of E, this is the compression force, this distance is X, and this ordinate is 0.45 FCK. Now balancing the forces, P plus force in the bolt should be equal to compressive force. From this, P plus FB will be equal to compressive force is 0.45 FCK into contact area is B into X. And taking moments about the central axis, say CC, clockwise moment is P into E, which will be equal to anti-clockwise moments, that is FB into A, plus compression force into its CG distance is, this total length is L by 2 minus the X by 2. We know P into E is M, so M is equal to FB into A plus C into L minus X by 2. And taking this to the other side, M minus C into L minus X by 2 equal to force in the bolt from this equation will be equal to 0.45 FCK B into X minus P. So substituting that here, 0.45 FCK into B into X minus P into A. From this 0.45 FCK B into X into A minus P into A will be equal to M minus C into L by 2 plus C into X by 2. Taking X to the other side, 0.45 FCK B into A minus C by 2 whole into X will be equal to M plus PA minus CL by 2. Substituting the value of C, that is equal to 0.45 FCK B into X in this equation, that is M plus PA minus C into L by 2. So L by 2 into C is 0.45 FCK B into X will be equal to X times of 0.45 FCK B into A minus half into 0.45 FCK B into X. From this 0.45 FCK B is common, that is Ax minus x square by 2 plus L by 2 times of 0.45 FCK B into x will be equal to M plus P into A. So 0.45 FCK B is common, then this becomes minus x square by 2 plus Ax plus L by 2 into x will be equal to M plus P into A. And from this minus x square plus 2ax plus lx will be equal to 2 is taken as LCM and it is taken to the other side. So 2 times of M plus PA by 0.45 FCK into B. So the quadratic equation will be x square minus 2a plus L into x, minus of minus it becomes plus 2 times of M plus PA by 0.45 FCK B is equal to 0. Solving this, that is x equal to minus b, minus of minus, so plus, so 2a plus L plus or minus under root of b square, that is 2a plus L whole square minus 4ac, 4 into 1 into 2 times of M plus PA by 0.45 FCK into B under root by 2 into A, that is 2 into 1. From this x will be equal to 2a plus L by 2. Out of plus and minus we'll consider minus into under root of taking a inside or taking 2 common. There is 1 by 2 outside, so taking 2 square common, this becomes a plus L by 2 whole square minus 2 times of M plus PA by 0.45 FCK into B. 2 comes outside and it gets cancelled. Here it is a plus L by 2 minus under root of a plus L by 2 whole square minus 2 times of M plus PA by 0.45 FCK into B whole root. So this is the expression to find x, and whereas force in the bolt is given as 0.45 FCK Bx minus P. Finding the value of x from this expression, we can substitute and find the value of force in the bolt Fb, and this force in the bolt should always be less than or equal to tensile capacity of bolt for safety. This is force in bolt. And considering this as x and our distribution approximated as rectangle, and let us say this is y projection, assuming x is less than y, then bending moment at critical section, that is face of the column, will be equal to 0.45 FCK into x into b into CG distance is y minus x by 2, and we know moment capacity is 1.2 ZE into Fi by gamma m naught. So substituting 1.2 into ZE is Bt square by 6 into Fi by gamma m naught, equating bending moment to the moment capacity, we can find the thickness, that is 0.45 FCK B into x into y minus x by 2 will be equal to 1.2 times of b into t square by 6 into Fi by gamma m naught. From this b and b gets cancelled, so thickness will be equal to 6 times of 0.45 FCK into x into y minus x by 2 into gamma m naught by Fy divided by 1.2 whole root. If x is greater than y, then bending moment will become 0.45 FCK into b into x by 2 will be the CG distance then. Whereas depth of anchorage required in anchor bolts, that is, let us say it is LD, then LD will be equal to Fs into phi diameter of bolt by 4 times of tau BD, where Fs is Fyb by gamma m naught. So LD will be equal to development length or anchorage length, which is equal to Fyb by gamma m naught into diameter of bolt by 4 times of tau BD, where tau BD depends on grade of concrete, whereas this is our base plate. Design of weld includes determination of force in the weld and length of the weld. Let us say this is the force in the weld and this distance will be d minus thickness of flange. Our P load gets transferred directly through the contact between column and base plate, whereas moment M will now be equal to the force in the weld into d minus thickness of flange. From this, force in the weld will be equal to m by d minus thickness of flange. So weld should be designed for this force, and taking this force should be equal to length of the weld into throat thickness into Fi by root 3 into gamma mw. Equating, we can find, assuming size, we can find length of the weld and check for available length.